Okay, we're starting something today called curve sketching. You didn't get one? I'm sorry. Let's keep preview here. He probably does. Right. Okay. So we're taking everything you've learned so far and shoving it all on one piece of paper so that you can predict, you can sketch out the graph of something without typing it into your calculators, what's happening. So we've got our first little problem here. You probably don't know by looking at that what the graph looks like, but by the end of this page, you'll be able to draw it out. Domain, what are we talking about with domain?
X's.
X's. What can X not be?
Undefined.
Is there anything you can put in for X and it will make an impossible problem?
No.
No. Everything works, so we put negative infinity to positive infinity. Now the range can be a little bit tricky. I'm going to put a little star by it. I would save the range until after you get the graph finished. Just don't forget to come back and get it. It's a little hard to figure out. F of X has an X-intercept at. How do I find an X-intercept? It's where Y equals 0. So if Y is 0, and we have a fraction here, aren't we really only concerned with the numerator, the top? Because if the top is 0, then the whole thing is 0. So in other words, we know that if Y is 0, then X had to be 0. The Y-intercept is where it crosses the Y-axis, and so X has to be 0. If I take a 0 and I plug it in for my X's, what do I get? 0. So if I plug in a 0 for X, my output is 0. Then it asks for the derivative of X, F of X. Okay, we can do that. What do we have to do? Quotient rule. So we say bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And we want to simplify it, make it a little bit prettier. So I've got an x squared, that 1 doesn't really affect it, minus x times 2x. So minus 2x squared. X squared minus 2x squared is negative x squared plus 1 over x squared plus 1, the quantity squared. And there's your derivative. Now when I go to write it in the blank, there's not a lot of space. Why in the world would a teacher count this wrong? It looks like I'm saying negative x squared plus this fraction is what it looks like. How do I fix that? Yeah. Make sure you have parentheses, please, so I know that you know what you're doing. Then it says the derivative of f of x is 0 for what values of x? So we're going to set just the top equal to 0. And we only need the top because that's what makes the whole thing 0. So if I subtract 1 from each side, divide both sides by a negative, square root both sides, and when you square root both sides, please remember positive and negative. So it's for positive and negative 1. Then it says f of x, or the derivative of f of x is undefined for what values of x? What's going to make that thing undefined? And is that bottom ever going to be 0? Nope, not in this one. So none. Then it wants to know where the function is increasing and decreasing. How do we figure that out? Yeah, we do our little number line. And if I were you, I'd set it kind of off to the side here because we're going to need that space in a second, trust me. So we have a negative 1 and a positive 1. And we test each section. Where do I test the sections? In the first derivative. Good, because it's the first derivative number line. So if I take a negative 2 and I plug it into the first derivative, negative 2 squared is 4. It's the opposite of that, bless you. So negative 4 plus 1, I have a negative on the top. On the bottom, aren't I always going to have a positive on the bottom? Yeah, because you're squaring it. So negative divided by a positive is a negative. Take 0 and plug it in. And I wind up with a positive 1 over a positive, so that's positive. Take a positive 2 and plug it in. And don't I get the same answer I got when I put in a negative 2? Yes, I do. So now you can see increasing and decreasing. So we are increasing from -1 to +1, and we are decreasing from -infinity to -1 and from 1 to infinity. Are there any questions so far? Great. It wants to know about the local max and the local min. This is where you can do your little, it's decreasing, increasing, decreasing. Even if the actual graph doesn't look like this, drawing that picture can help you see where there's a local max or a local min and a local max. So there's a local minimum at -1 something and a maximum at 1 comma something. How do I get the something? Where? Original, because I want to know where that maximum is on the original graph. So I take a 1 and I plug it in, and I'm going to have 1 over 2, so I have a half. Take a -1 and plug it in, and I have -1 over 2, so I have -1/2. Then it's asking for the second derivative. Write very small. I'll zoom in so you can see it, but we need to write kind of tiny. So second derivative equals bottom times the derivative of the top, which is going to be -2x, minus the top times the derivative of the bottom, which is going to be 2 times the inside gets left alone. That was an exponent of 2. It's now an exponent of 1 times, you have to finish the chain, the derivative of the inside is 2x. Don't forget to finish the chain. All over the bottom squared. So x squared plus 1 is now to the 4th. And now it's just, can you put it together and use your 8th grade math skills? Don't say no, you can do that. So I'm going to go ahead and take care of this little guy right here. I'm going to square that guy, and so I wrote too big already. I'm going to write underneath because I know how much space I need. I'm going to have x to the 4th plus 2x squared plus 1. And I still have to multiply that whole thing by -2x. Then for the second term, I've got this 2x times this 2. And I'm going to distribute that to this guy right here all at one time. So 2 times 2x is 4x. And I'm going to distribute it. So I have 4x times -x squared is -4x cubed. And then I have 4x times this 1. So I have plus 4x. And I still haven't touched the x squared plus 1. And that is all over x squared plus 1, the quantity to the 4th. Now I need to distribute my -2x to all of these little guys. So I have -2x to the 5th. I'm still probably writing too big. Minus 4x cubed minus 2x minus, and I'm going to keep my parenthesis here, and I'm going to go ahead and FOIL these little guys right here. So the first terms, I have -4x cubed times x squared is -4x to the 5th. The outer terms are going to give me -4x cubed. The inner terms get me +4x cubed. They cancel each other out. So I've saved some space there. That's good. The last terms are 4x times 1, so I have 4x. And all of that is still over x squared plus 1, the quantity to the 4th. Why am I not multiplying the bottom out? Because it's not really going to matter. We know in the end it's going to be a positive, and that's kind of what we care about. And then we simplify the top again. So I have -2x to the 5th minus negative, so plus 4x to the 5th. So I have 2x to the 5th. Is that right? This is not going to come out right again. I don't think this is going to work. Did I forget something? I feel like something is messed up. I feel like this is supposed to be a negative. Alright, we're going to keep going, but I'm pretty sure something's not going to turn out right. I'm going to have negative 4x cubed. Then I have a negative 2x minus 4x. So I have negative 6x. Bless you, all over x squared plus 1, the quantity of the fourth. And I think that's our derivative. Even though I'm kind of uncomfortable with this, I feel like I'm missing a negative somewhere. All right, so let's write it in the blank. Let's hope I don't have to go back and do this again. So I'm putting parentheses around my numerator so that Mrs. Major knows. I know that the whole thing is a numerator. Divided by x squared plus 1 to the fourth. It wants to know where the second derivative is a 0. So we set the top equal to 0. And when I do that, I'm going to go ahead and factor. And I'm going to pull out a 2x. When I do that, I've got x, whoops, to the fourth. My bad. Sorry, that's a 4. Minus 2x squared minus 3x. Yep, 3. Sorry, I was thinking ahead, trying to make sure this is going to work out. Sorry. We can factor again. Try not to write on your little chart here. You're going to need that. So we have x squared and x squared. I know that much. I know I have to have a 3 and a 1. I don't have a choice. And it's a negative 3 and a positive 1. Right?
Yeah.
Still doesn't work out right. Yeah, it'll be fine. Okay, so then I'm going to draw an arrow down here. My x has to be 0, or if you set x squared minus 3 equal to 0, what do you get? Good, positive and negative radical 3. Good job. And what happens if you set x squared plus 1 equal to 0? You get an imaginary number, right?
Yeah.
So I think we're good. So for the x's that are 0 and positive and negative radical 3. It says the second derivative of f of x is undefined for what values of x? Yeah, I heard it. None. It doesn't matter what you put in there. You're going to be fine. You're never going to get 0. Concave up and concave down. How do we get that? Right, number line for the second derivative. So I've got a 0, I have a positive radical 3, and I have a negative radical 3. Let's put in something really far away from this, like, I don't know, negative 3 into the second derivative. And I don't really want to do that in my head, and you probably don't either. You do have a calculator. Let's use it.
Machine gun.
Sorry. So we have 2 times negative 3 to the 5th. Why did I have to put parentheses around that negative 3?
So that way.
Right, otherwise they're going to tell you it's 3 to the 5th and it's the opposite of it. Now in this case, because it's a negative, it works out fine, but if that were a different number, it wouldn't necessarily work out. Like if this were an even number, it wouldn't work out. Do what? I'm just putting a negative 3 for the number line. Good question. And that's to the 3rd minus 6 times negative 3. So on the top we get a negative, and on the bottom we get a positive. Wait a minute. Something's wrong. Because I know what it's supposed to turn out to be. Did I type something in wrong? Did you guys get a negative? Okay. Negative 1. We could probably do that in our head. If we put a negative 1 in here, we're going to have, that's going to be a negative 2. plus a 4. So negative 2 plus 4 is a negative 2. It's going to be plus 6. Negative 2 plus 6 is positive 4, so it's positive over a positive. So we get a positive. If I put in a positive 1, I'm going to have 2 minus 4 is negative 2 minus 6. Negative over positive, won't that be a negative? And then if I put in, like, say, a positive 3, on the top we wind up with a positive, and the bottom we know is a positive, so we get a positive. So now you can get your concave up and concave down. Concave up is from negative radical 3 to 0, and from, whoops, radical 3, my bad, radical 3 to infinity. Concave down is from negative infinity to negative radical 3, and from 0 to radical 3. What about inflection points? Right, it changes at negative radical 3 and positive radical 3. So we have negative radical 3 comma something and positive radical 3 comma something. How do I get the something? Plug it into the original. I'm going to use my calculator. So I have radical 3 divided by, well, 4, because radical 3 times radical 3 is 3 plus 1 is 4. Mm-hmm. I can't hear you. What, hun? Because I skipped it. Thank you. Good catch. About 0 comma 0. My bad. Thank you. Yep, 0 is a point of inflection. Negative radical 3 is just going to make that, should be a negative. So we're going to have negative 0.43. Let me zoom in so you can see that. So there's our points of inflection. The next question asks about vertical asymptotes. Where would we find vertical asymptotes? Where x can't be, right? Where it's undefined. Do we have any place where we're undefined? Nope. So to show me that you really did think about this and you didn't just skip it, put a big O X over it. Are we going to have any horizontal asymptotes for this thing? Maybe, maybe not. We don't know. We're not sure. Slant asymptotes. Let's just see. This is something you can do. And I don't like the way they wrote this. They kind of messed up. We're approaching negative infinity and we're approaching positive infinity because you can't approach infinity from the right. That's silly. So just kind of cross through those. Okay, we're going to approach negative infinity. This is sort of our beginning piece. And remember, if Bill Gates lost $1, like, he wouldn't be that concerned with it, so we don't really, that 1 doesn't really do anything. So if we have x over x squared, what would you reduce that to? 1 over x. So if you have 1 over x, and if you put negative infinity, negative gigantic number in there, we're really close to what? 0. So there's our first blank. We're approaching 0. Positive infinity. Same process, but now I've got gigantic number on the bottom. We're really, really close to 0. It's a teeny tiny number. So if we have a horizontal asymptote, we know we don't have a slant one. So you need to cross through it so I know that you thought about it. And you knew you didn't have to do it. And now we have all the information we need to graph it. Now I know for sure that there's a point at 0, 0. Because that's my x-intercept, my y-intercept, and it's a point of inflection. So put a point at 0, 0. Also, because these are teeny tiny, and I know how this is going to turn out, every 2 boxes is 1 unit. So put a 5 out here, a 5 up here, a negative 5 down here, and a negative 5 back here, so that I know you know how big those are. All right, so we have a point at 0, 0. Another point that we know for sure is on the graph is 1 comma a half. That's a maximum. So 1 comma a half. Another point that's for sure on the graph is -1 comma negative a half. That's a minimum. -1 comma negative a half. And I also know something a little bit about that. I know that between those 2 points, it's increasing the entire time between -1 and +1. And now I can look at the concave up and concave down, and I can say, okay, oh, it's kind of like here-ish, isn't it? -1 to +1. So it's kind of like we must be concave down. It switches to concave up and then concave down again. So I'm thinking it must be sort of like part of a frowny face here and part of a happy face here. Or I mean part of a, reverse that, happy face and then sad face. Because of the concavity. It says as we're headed toward -infinity. So we're headed left for forever. We're approaching 0. Okay. And it says as we're approaching positive infinity, we're headed toward 0. That's it. You can check it by plugging it in your graphing calculator. So if you plug it in, la-di-da. That's it. You can fix your window to make it look like the one that they gave you.
So that's range.
Yeah, we'll go back and pick up the range. So there's the graph. They match. We did a good job. For the range, what y values does the graph include?
Negative.
Good. -1 to +1. And do we need brackets or parentheses or both?
Bracket.
Bracket, because it includes -1 and +1. And that's how you do these problems. Let's do the next one together. Alrighty. It's fancy for y, so we just rewrite the problem. The domain, is there anything x can't be? Nah, we're good. -infinity to +infinity. Let's skip our range until the very end. X-intercept. How do we find the x-intercept? Isn't it where the y is 0? So we have 0 equals 3x to the 4th plus 4x cubed. I can factor this. I'm going to take out x cubed. I'm left with x plus 4. If I set each of those equal to 0, I have x could be 0 or -4/3. So there's an x-intercept at 0, 0, and -4/3 comma 0. The y-intercept occurs when we plug in 0 for x. If I put in 0 for x, what do I get for y? I heard it. 0. First derivative of f of x looks like it's going to be 12x cubed plus 12x squared. And it wants to know where that derivative is equal to 0. So I have 0 equals 12x cubed plus 12x squared. Factor. I'm going to factor out a 12x squared. And I'm left with x plus 1. So it looks like x could be 0 or it could be -1. Everybody with me so far? It wants to know where the derivative is undefined. Do we have any place it's undefined? Nope. So we say none. It wants to know where it's increasing and decreasing. I'm thinking first derivative test will get us that. So it's a 0 and a -1. If I take a -2 and plug it into this, I have -8 times 12 plus 12 times a +4. I think I'm going to wind up with a negative. If I plug in -1/2, that's kind of tricky, so let's just plug it into our calculator here. 12 times negative a half. Whoops, I need parentheses. Cubed plus 12 times 0.5 squared. Whoops, negative 0.5 squared, my bad. Should wind up with 1.5, so that's a positive. If I put in a positive 1, I wind up with a positive. So we are increasing from negative 1. Do I need to say negative 1 to 0 and then 0 to infinity, or can I say negative 1 to infinity? I can say negative infinity. When would be a situation when I would have a graph like this and I couldn't say negative 1 to infinity? If 0 was undefined. But there is a value for 0, so it's fine to just say negative 1 to infinity. Decreasing is from negative infinity to negative 1. Local max and local min. Let's think about this. We are decreasing and then increasing and still increasing. We have no max. Good. We only have a minimum at negative 1 comma something. Take the negative 1, plug it into the original. It's going to give me a 3 minus 4, so a negative 1. Negative 1, negative 1. Second derivative of f of x. 3 times 12 is 36. X cubed becomes x squared. Plus 2 times 12 is 24. X squared becomes x. It wants to know where it's going to equal 0. So we factor out, I don't know, 12x. That gives me 3x plus 2. So x could be 0, or it could be, good, negative 2/3. And it wants to know where the second derivative is undefined. None. Concave up and concave down. Second derivative, number line. And on that number line, I need a negative 2/3 and I need a 0. If I plug in like a negative 2, I'm going to wind up with a positive. If I plug in a positive 1, I'm going to wind up with a positive. The sketchy part is right in the middle. So we plug in something like negative a half. And when we do that, we get a negative. So now we can see our concave up and concave down. We are concave up from negative infinity to negative 2/3 and from 0 to infinity. We are concave down between negative 2/3 and 0. How about inflection points? At negative 2/3 comma something and at 0 comma something. If I take a 0 and I plug it into the original, I get a 0. If I take a negative 2/3 and plug it into the original, I get a decimal, or you could put negative 16/27. I'm going to put negative 0.6. Vertical asymptotes. Do we have any? Nope, so I can X that out. Horizontal asymptotes. Are we going to have any? No, it's not a rational function. It's just a polynomial. And that also tells us we won't have it. I'm going to make this 1, this 2, this 3, and so are you. This is 2. This is negative 2. And that's negative 3. Sketch it on your own. points we know for sure that are on the graph is our x and y intercept. So those two are x-intercepts, and then the one on the right intercept. We know that this point down here is a. We also know that this point right here-ish, it's a sketch, it's not exact, is a point of inflection. So we know for sure that those 4 points are on the graph. Once you get all kind of in, you need to figure out the lines and which way that they go. When I look to the left of this guy right here, -4/3, I know this. I know that we are still decreasing, still cave up. And I know that this point is a point of, is our local minimum. So I know that we're back up. Tell what happens at -1 because it says it's now increasing. So I'm going to increase.
To kind of make sure you're on track. Actually, we're skimming